For the goal for us today is when you leave the classroom, you will understand how to perform molecular formula problems. Okay, but first, I would like, actually, yep, to do this. All right, just to give you a preview. All right, this is chapter 8. This is chapter 8, chemical reactions. What you will do is, if given the name of your reactant, we will predict the correct product by name, but also get the balanced chemical equation. So ladies and gentlemen, we need, without hesitation, to just know, oh, aluminum carbonate, Al plus 3, CO3 minus 2, lowest common multiple 6, and so on. So if we got a 30 out of 40, but if we can't start with the correct formula of the reactant, so it's a skill that we will be applying the remainder of the year. You know, if you have questions, concerns, absolutely, I will address that with you. All right, so transitioning. Hello, I hope your math went well. I got an email. All right, so can we turn to page 27 in our packet? We, of course, will be calculating today, so we need our calculators. And if you need to also get your periodic table, if you can't easily see the ones we have. This is the last portion of this chapter. So we have shown understanding of formula writing, naming. We've done percent composition. We've done empirical formula problems. All right, Tuesday is an E day for us. Wednesday is an A day. Thursday, we will show our understanding of the problem solving of this chapter. Okay, and this is the last piece. So we said empirical formulas are the simplest formulas. Molecular can be reduced by the same common factor the subscripts can to get a different formula. All right, Troy, this one's here. And let me zoom in. So we're page 27, yeah? All right, just make it a lot bigger for us. C6H12O6. The question is asking, what is the empirical of this? So, is this a molecular formula?
Yeah.
How do you know?
Because it's a covalent bond.
Well, first, are you correct? Is this a covalent compound?
Yeah.
Yeah, made of on those. All right. Next. Now, usually we can see molecular with covalent, but not always. So that's not the designating factor. We look at our subscript. Oscar.
You can just simplify it, and then if you can simplify it, it's covalent, and if you cannot, it's already in empirical form, then it's ionic.
Oh, okay. Be so careful associating types of compounds with being able to reduce or not. Okay, ionic compounds should and will be in empirical form. Okay. Covalent can be empirical or molecular. But to decide if it's empirical or molecular, we need to examine our subscript and ask, is there a value that I could extract, divide all of the subscripts by, and get a different set of whole numbers? I like that you said, Oscar, simplify it. Simplify it. Okay. If you can, then it's molecular. So Maddie, is there a value that I can reduce all of these by? 6. And then I will get,
CH2O.
yes. But Noah, I bet you saw a different way that we could have reduced. So this is extracting or dividing by 6. What else could we have done?
3.
Yeah. And then we'll get C.
4.
Yeah. How about 2? And then we'll get C3H6O3. So there's multiple ways that we could have simplified or reduced down. That just means if you just have one way that it can be simplified, that means the original is a molecular formula. Even though you just take these multiplied by 3, these multiplied by 2, these multiplied by 6, and you get the molecular formula. They are all different because they have different ratios of elements. Empirical, if I multiply all of the subscripts by 6, I get that. If I multiply all the subscripts by 2, I get that. And so we've just looked at, well, how do we go from the molecular to the empirical? But then we would just multiply to go in the reverse direction. We need to just have been exposed to that. All right, looking at your amazing faces, I can tell by your eyes, you did not just pay attention. Not all, but a lot. Questions? So, next page. Abby, Kay, I would love for you to choose any number 1 through 6 on page 28. Excellent, thank you. All right. Can you please read it? Please read number 3. Okay. What do we ask for? Of course, that last sentence. What is the correct formula? Anything different? Anything different about this problem than what we've been looking at, Caitlin? Oh. Now, we're told the name, but that is a different kind of chemistry that we use to come up with that naming. So that name, it should be unfamiliar. We can't get the formula with the chemistry that we've learned from that name. Okay, but it looks quite similar, doesn't it? That you've been given the percent mass of your element. But it is asking what is the correct formula. So that is saying how it exists in our world. If we take a look, number 1, what is the compound's true formula? Number 2, what is the molecular formula? What is the molecular, and so on. So if you read that wording, that means, dun, 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 this is the method that we are applying. And you will love this because first, what we do is approach it like it's an empirical formula problem. And we get the empirical formula. You already know how to do that. So Tyler, I'm going to start number 3 by saying, okay, I have 80% carbon and 20% hydrogen. I'm going to pretend 100 grams of sample. Is that okay? So I have 80 grams of carbon and 20 grams of hydrogen. What do you do from there, sir? We treat it like it's an empirical formula problem.
Wouldn't you take on the table,
You got it?
mass over, or that's like over the one,
All right. What unit? So percents, the whole reason we assume 100 grams is we can't proceed mathematically with a number as a percent. We make that step of assuming 100 grams so that the percent directly can be written as grams. Now, as soon as I see a G as a chemist, the unit of G, I like that much better. I know I can work with grams, not percents. If I have the mass of every element, okay, that's better than a percent. But what's even better when I'm trying to get the formula than the mass of the element? What unit? It rhymes with gold. Sold. Yes. All right. To cancel grams. And we know the average atomic mass is what we use to the 100th minimally to get to moles. Hydrogen, 1.01. Okay. Leah, do you mind giving us the answer for the moles of carbon, please?
I got 6.7.
And with 3 sig figs, please.
6.6.
And does the last 6 round? Okay, very good. And then our hydrogen, so we'll just take the 20 divided by 1.01, and 3 sig figs, 19.8. Okay, obvious that then. So do I have 7 carbons? Oh wait, that would be like 2/3, huh?
divide 6.6
Excellent. So that's usually the step we forget. Excellent, excellent. Yes, sir.
Doesn't the 1820 not contribute to the plate
Okay. Noah, that is the whole reason for significant figures. It's because our measuring tools are limited in their precision. They're limited. Yeah. By do they, read to the 10th or the 100th or the 1,000? Yeah. So that's the whole reason we do sig figs. So no. Okay. The 1 would not because, okay. So excellent, Avi. Thank you. So we get 1 and then 2.97. And remember, I told you it will be 500ths below or above whole number and a half, whole number and a third, whole number and 2/3. All right. So my empirical formula, and I can't reduce that down by the same factor to get anything else. So this is my empirical formula. And if they were asking for empirical, we'd be done. Yes, ma'am.
I forget how it's known what order.
Okay, wonderful question. If there's a metal given as one of our elements, we know metals can only and will only form cations, so they will definitely be written first. And we've worked with a good amount of formulas that I think if a metal was there, we'd like, oh, that's sodium sulfide or something else. Okay. But whenever they're covalent, I venture to say 97% of the time, 97% of the time, so the overwhelming majority of the time, the order that the elements are given in the formula in the problem will be the order that you'll write. That's usually what we do. So for example, number 1, they give you carbon first, then hydrogen, then oxygen. So that's the order, that I would write them. The next one. Carbon, hydrogen, oxygen. That would be the order. So I know Troy is thinking, but Miss Garrett, if hydrogen is there, it's an acid. well, they would convey that to you if we need to write hydrogen first. Did that address what you need? Okay. So again, the majority of the time, it's just going to be the order that you're given your elements in the problem. Okay. If it asks for empirical formula, we'd be done. All right. Again, it's asking for the true, and then we're given this information. All right. Well, Troy, back to you, sir. Okay, we're told the molecular weight. Now, we could also call that molar mass, formula mass, and we're told the molecular weight, the molar mass is 30. Shame on this problem for not giving units, but they trust that we know the units. What would be the unit on that?
Moles or grams.
So we know, we don't use the term weight. We just know, like, oh, if someone's just using it, they really mean mass. Molar mass. Molar mass. We're not just calling it mass. We're not just calling it moles. Are we calling it molar mass? Yes, you do. I'm trying to, okay. We learned chemistry, specifically honors chemistry. But I also am very fortunate to teach the second year advanced course AP chemistry. Okay, so molar. Now, of course, how do we usually say it? This is, I'm sorry, AP chemistry, honors chemistry. Okay. So it's chemistry, but it's this specific type. Chemistry, this specific type. Okay, so it's the mass, but of what? That's what I'm trying to show, okay? So usually we say honors chemistry. Well, yeah, it's gonna be a mass, but a mass of what?
A mole.
Okay. The mole of what?
The molecule.
I like that. So what unit will this have?
Grams per mole.
Oh my gosh, yeah. There's that many grams of this ethane in every, how many moles?
Yeah.
Yeah. That's the molar mass. Yes.
Just say formulated.
Okay, formula unit would be 1. So, it's 30 grams in Avogadro's number of formula units. Would that be okay? All right. Just like, well, we're good for now. Okay. All right. What can this help us with? This is the mass of 1 mole of what the real thing is. Remember, how did we recognize that this was a molecular formula? We could reduce it down by a factor and then get other whole number ratios. B2H6. We could reduce these by 2 or simplify by a factor of 2. We are after what the multiple is. What did we just find? We found in number 3, this. So we know that if we reduce this by 2, simplified by a factor of 2, we would get BH3. But this is what the problem is asking for. What is the molecular formula, the true formula? Elena. Yeah. Yeah. So this could be 2, 3, 4, 5, 6. Did we see like, reducing, by 6? So how do we find that? That's exactly what we need to do. Abby.
If you know it's 80% and then 20%, couldn't you take those like 80% of 30 more mass and the 20% of it and compare what that number would be to the CH3?
If we would take 80% of this, 20% of that, and then follow what we've done here,
Yeah.
you mean? Those steps will give us the empirical formula. Okay, but keep thinking, keep thinking, keep thinking. So Elena got us to, okay, we need to figure out what we need to multiply the empirical formula by. 2, 3, 4, 5, 6, or something. Abby's saying, okay, we're given the percent. Yeah, and if we would do it by this, will that give us, it'll give us different numbers, but we'll end up getting the same simplest ratio. We are after the multiple. What can we use this for? That's the mass of the multiple when I have 1 mole of it. Brilliant students. Abby.
What you do what you found for hydrogen, if you take the moles you found from the empirical and then put them in a way where like it would like the 30 grams of ethane would cancel out with like the 6, or you can do like the 1 mole of ethane would cancel out with like the 6.6 moles of carbon and like multiply.
Like that?
Like put the 6.6 on top so they would cancel out.
Okay, but will moles of ethane cancel with moles of carbon?
No.
The only thing I would not want us to ever do is nothing. So I love that you gave a thought of, okay, well, what will that do for us? Go ahead, Noah.
You have to find the average atomic mass of ethane and multiply that.
Okay, hang on 1 second. The average atomic mass would be of single elements. So if we want to find the mass of the compound, we're given that. Okay, keep thinking, Noah, keep thinking. Guys, we know this.
So do we have to take like 12.01 times 1 and then 1.01 times 3 and add it up?
And what will that give us? So if we look at, okay, 1 carbon, 12.01, plus 3 hydrogens, 1.01, yeah? That will be,
Like the mass of the like what we got.
okay, just mass gram or,
The mole.
yes, and Troy, what is the mass of a mole of a compound?
Grams per mole.
Yes, and we give that a nickname.
Molar mass.
Again,
Molar mass.
in your deepest voice,
Molar mass.
in your highest voice,
Molar mass.
in regular Troy voice.
Molar mass.
What is molar mass? The mass of 1 mole of?
Compound.
Yes! Yes. Noah, what do we call it if it's the mass of 1 mole of an element?
Average atomic mass.
Yes. So Maddie, if we get this is how many grams there are in 1 mole of CH3. You said it. This is, Troy, this value is the what?
Molar mass.
Of,
CH3.
which is,
50.0.
wait, which represents,
The empirical formula.
all right, so this is the molar mass, we call molecular weight formula mass of the empirical formula. Okay, so we found this, because we did all the work to get that. We know the mass of the molecular formula. So how many of these, Avi, make the molecular formula?
2.
Yeah, how do you know that?
It's 30 divided by 2.
So what we're trying to find is the multiple. How many of these make that? So if we take the molecular formula mass, 30 gram per mole, divided by the empirical formula mass, we get the multiple. Now, we're rounding, and 30 divided by 15.04, 2. And so the molecular formula, Maddie,
C2H6.
C2H6. Oh, phew. Yes.
Could it be like CH3 and then in parentheses?
In our kind of chemistry, the way we do, no. But organic chemists might write it that way, but the way we would, no. So whenever you find the multiple, you will apply that through to the subscripts, not in parentheses. Max.
Wait, so where are you getting the 15 from the empirical formula mass? Yeah, but like, where's that coming from though?
Who can you ask?
Cordelia?
Yeah, I think so you'd add the 12.01 plus the 1.01s for the hydrogen, which would be your.
Oh, okay, so that's, okay, I know, I got it now. So it's all the average atomic masses added up, okay.
Okay. All right. Leah, Abby chose a great one to start with. She chose 3. Could you please choose another one amongst these?
4.
All right. So I will do it simultaneously. Go ahead and jump in and we'll check in with each other. whenever we divide by the smallest amount of moles and then get what may directly be our subscripts, or we may have to multiply through by 2 or 3, these will not differ more than 0.05 of a gram. But for some reason, whenever the problem is given, usually, like in this case, we're arcade around. We know it has to be a whole number. I'm sorry, that makes me a little uncomfortable. We definitely know that we won't liberally round here, but we can take that leap there. No,
I thought for that number we could round to like 1 and 2/3 as well.
okay, remember 1 and 2/3, that would be 1.66, right? So no, I'm telling you that here, these values will be whole numbers and a half, 1/3 or 2/3. But these, let me think if I have a good like theoretical answer for that as to, because wouldn't that mean, wouldn't that mean that, because this is the empirical formula. Yeah, done, period. This is the molecular formula. And so if this didn't end up being a whole number, then that couldn't be true, right? That would mean like 1 and 2/3 of those is in that. If we said it was 1 and 2/3, well, how can you have 1 and 2/3 of an empirical? You see what I mean? So that has to be a whole number ratio. Maddie, do you have another?
So even if you get like 1.51, you still round it to 2.
We would. I hope we wouldn't.
Well,
But yeah, just as an example, we would. Yeah, go ahead, Sean.
So you just said we can't have 1 and 2/3. We have 1 and 4/8 technically. It's 1.8 full rounded.
Wait, huh?
Because you said you can't round it.
Wait, 1 and 4/8.
Or I mean, 1 and 4/5. Is what I meant. For 1.8.
Oh, well. Somebody must have made an error when they got that. But I don't know what else to say. Like, I know what you're saying, like, well, but like what? We're not gonna live around here, but based upon sometimes what we're given, we will just here. Okay, but believe me, I will make sure I'm choosing problems so we wouldn't like have a 1.51 situation. Okay, Abby.
So since CL is like the highest percent of like what it says in the formula, why doesn't it have the largest subscript?
What is the answer to that? Could you ask that again? That's a great question.
So since CL is like, it has the highest percent in the equation, like why isn't it subscript high?
Go ahead. What were you going to say? Same thing?
This massive group,
Okay, go.
they might be more than one of it, like make up the, what's that? Empirical. Oh, wait.
Subscripts. Subscripts. Are these subscripts a direct result of mass? It's mass, but then how many moles does that represent? So yeah, it can have the greatest mass contribution, but this also has the greatest average atomic mass. So it ends up just being 2 moles of chlorine, where 24% of carbon is 2 moles. And then for crying out loud, 4% of hydrogen, because it's such a small average atomic mass, has more moles and then a bigger subscript. So it's not a mass, it's a mole ratio. Great. So good. So good. So good. Yes, Abby?
So does the final answer mean that, 1 mole of CH2Cl would be C2H4Cl2?
What you just said, your beautiful sentence you just said, would 1 mole of this be that? No, they're different compounds. When we found this is not our answer. This just gets us to the answer. This is the answer. That's it. If the only relationship is if you reduce these down by 2, you get that. But no, this just allows us to find that.
Oh, okay.
Okay. All right. In your packet, page 29. Page 29. All right. Incredible, incredible, incredible students. So Thursday, next Thursday, we will get a set of problems like this. And I will ask for us to show our understanding of how to find percent comp, how to get simplest or empirical formula, and then molecular formula. So for Tuesday, could I ask us to please answer 1, 5, 1, 5, 7, 11, and 12. Okay? 1, 5, 7, 11, and 12. So it won't be a list of compounds, a list of formulas like our quizzes, but we're gonna have to know how to write formulas and so on, okay? I wish you a phenomenal 4-day break before third 9 weeks.
Do we keep the?
Yes, 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 yes. And ladies and gentlemen, if tomorrow, of course, I'll be working on grades. So by the end of the day, if you feel that a correction needs to be made or if you have a question, please send me an email. Enjoy your 4-day break. Have a great, great, great weekend.